Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing regarding the concept of thermal stresses. So basically what is a thermal stress? Thermal stresses are the stresses which are induced in a body due to change in temperature. So I repeat it. So when an object is subjected to change in temperature, then some amount of stress will be induced in a body due to the change in temperature. So such stresses are called as thermal stresses. So thermal stresses are basically set up in a body when the temperature of the body is altered, means it is raised or lowered, and the body is not allowed to expand or contract freely. So, in such instances, thermal stresses will be developed. But if the body is allowed to expand or contract freely, then there will not be any restraint condition which is developed. So therefore no stresses will be set up whenever the body is allowed to expand or contract freely. So Thermal stresses. Thermal stresses are the stresses which are induced in the body due to change in temperature, and whenever the body is allowed to contract or expand freely, then there will not be any stresses developed in the body. So next, coming on to the concept behind the thermal stress, that is, I have considered a body so which is heated at certain temperature. So you can just observe here. So so let L is considered to be as the original length of the body, and T is the rise in temperature. So E is the Young's modulus of the material, and alpha is the coefficient of linear expansion or coefficient of thermal expansion, and dl is the extension of the bar due to rise in temperature. So if at all, if the rod is allowed to expand freely, then the extension of the rod is given by dl is equal to alpha t times of L. So if the body is, or if the rod is allowed to expand freely, then the total extension will be equal to dl is equal to alpha times TL. So this is shown in figure 1. Figure A, wherein AB represents the original length, AB represents the original length, B dash represents the increase in length, that is dl. So due to the temperature rise. Now suppose that an external compressive load of magnitude P is applied at B dash phase, so that the rod is decreased in length from L to alpha TL. Why it is alpha TL? Because dl is equal to alpha TL, which we have derived it right now. So therefore, if there is application of load of magnitude equal to P, then there will be compression in the phase of B dash, so that the compression value, the dimension will be decreased to the extent of L plus alpha TL, L plus alpha TL to L, because L plus alpha TL is the final length whenever the body is free to expand. So if at all, if the restraint of P is allowed on the face of B dash, then L plus alpha TL changes to L. So next, compressive, if there is application of compressive load of magnitude equal to P, then in such case there will be resulting the compressive strain, that is nothing but decrease in length to the original length. So decrease in length is nothing but L plus alpha TL minus L. Why it is minus L means change in length to original length. So change in length is nothing but final length minus initial length. So here the final length is L plus TL, initial length is L. So change in length is L plus alpha TL minus L. So LL get cancels. So it is nothing but alpha TL will be the decrease in length. So divided by original length. Original length means the length for free expansion, that is L plus alpha TL. So therefore it is equal to alpha TL divided by L. So here alpha TL plus L is nothing, is approximated to L, because alpha TL is value is very less. So LL here get cancels here. So therefore the remaining will be alpha times of T. So next we know that stress by strain, the ratio of stress to strain within the elastic limit is called as Young's modulus. So I want what is the value of stress induced. So the stress will be equal to strain into Young's modulus. So therefore thermal stress is equal to alpha times of T into E, where alpha into T is the strain, E is the Young's modulus. So I repeat it. The thermal stresses are nothing but the stresses which are induced due to the change in the temperature for which the body is subjected, and whenever the object to which the thermal stresses are subjected, if at all if it is allowed to expand or contract freely, then there is no application of thermal stresses in that object. So therefore thermal stresses are only induced when there is a restraint condition. So whenever when the body is allowed to expand freely, then if at all if L is the length and DL is the extension of the rod, so then DL will always be equal to alpha times of TL. So this alpha times of TL is only for the condition wherein the extension the rod is allowed free to expand. So whenever there is a application of compressive load of magnitude equal to P, in such condition there will be compressive strain will be induced, so that the change in length will be equal to L plus alpha TL minus L. So therefore alpha times of T is the compressive strain value. So if we want to find out the stress, that is thermal stress, by using strain times of Young's modulus, it will be equal to alpha T into E. So by using this thermal stress, if I want to predict what is the amount of load or thrust on the rod, that is the value of P, so we can predict it as stress into area. So stress, we know that it is alpha times of TE into area of the cross section of the object. So this is the concept behind the thermal stresses. Thank you for watching. Please like, share and subscribe the video. Thank you.